Alright, I see that the O-rings are out for delivery, so we're going to start tearing this thing down. Alright, so I'm starting to take the attenuator apart, following the steps in the other guy's video. I'll just call out a few things here. You need a 2mm hex, a number 1 Phillips, an 8mm wrench, and a pair of tweezers. I'm going to put a mark here on this. It looks like this panel could potentially go on both ways. Put a little paint marker there just so I know how it lines back up. And I'm going to go ahead and continue taking this apart, and I'll be back in a minute. Alright, so I've got it apart partly. So we can see, here's our actual attenuator pad. Let me zoom in on that. That's the actual 10 dB attenuator pad, which on the newer serial number unit, it's built into this unit. Like I mentioned in the last video, on the older serial number units, they use an external SMA connector one, which would have been alright. But so the rest of the other ports on this are basically just used for a switch. So I'm going to try to rig the camera up here, and I'm going to show you how you can actuate these manually, and we can just, confirm the problem here. This is going to be kind of hard to record and do at the same time, but I'm going to try my best. So this is the front of the attenuator assembly, and you can see these leaves in here, and the piston assembly goes through. There's one there and one there, and they need to come up equally to, actuate. The piston needs to actuate to make contact with the attenuator or the switch portions. What you can do is, down here you can actually grab onto the part that moves, and you can move it manually. So if we look, let me see if I can do this while it's on camera. So if we look at those two leaves there on the left, they're both coming up evenly, so they make contact just fine. I wonder if you can see that too well. And the middle one, same thing, they move up evenly. And this one down in the end here, and this is the one where the O-ring fell out of, if you look at it. It's really hard to see on camera, but the one on the right moves up and down okay, but the one on the left is not moving up all the way. So this is our problem child right there. Alright, so I've got it apart. You can see our missing O-ring is, if this focuses correctly, it's this guy right here. So basically, from what I understand in his instructions, is you just kind of work these out sideways now. And then you replace these O-rings, which are 2mm by 1mm by 0.5, and put it all back together. So it looks like it should be pretty easy. I'm going to go ahead and replace all of these O-rings when they show up in a few hours here from Amazon. Alright, well, I got the watch O-ring kit. What a mess. These are all stuck to the case. There they are. The 2 by 1 by 0.5 are these ones here. Luckily they're not falling all over the place, but this is going to be a mess if I ever want to use these for anything else. So I got the 12 out that I need right there, and I'm going to go ahead and install those off camera. Alright, well, installing these O-rings is not enjoyable at all, but I found a little trick to getting them on there slightly easier. Pick it up with the you got to pick it up with your tweezers, then you got to kind of put it down this shaft here, and then you can kind of hold it with your finger and work it up here. I was originally trying to get them over this top part, and there's no way, so this seems to be working okay. Kind of don't want to stretch it too much. I'm going to have to do this off camera, but you get the idea. Okay, as you can see, I've got the pistons back in, new O-rings on there. They're nice. Go ahead and put this back into the other assembly now. Alright, well, I got it back together part way, and I'm going to actuate these and show you how they should look now. See, both go up evenly, so we've got it fixed. I'm going to go ahead and put this back the rest of the way, and then we'll get it reinstalled into the machine. Oh, and one other thing, here's the pad. You might not be able to see this. Let me see if I can zoom in. No, it's not going to go. I'll post a picture on the screen. Actually, I don't even have the right end up here. There we go. When I was testing that with an old meter, I kind of scratched the pads a little bit, but I think they'll be fine. Alright, let's get this thing back together. You might hear me listening to my own video here in a second because I didn't take nearly enough pictures before I took this thing apart. So I'm going to take a look here. So it looks like we've got the input connector connected back up. Got to get this limiter connector put in here. Let's see. It's not giving me a good time. There we go. Okay, and I've actually got this guy on the wrong way, because it needs to match the height of this one to connect into the amplifier board. I don't have a SMA torque wrench, so I'm going to be carefully tightening these down with an 8mm wrench. Come on. Really hard to work with the camera here. Put that in there crooked. Alright, let's get this guy started first. There we go. Okay, that's looking better. Okay. And the thing is, so the way this amplifier board goes in is like this. So you really got to have these things lined up, and then you don't get another chance to go in there and tighten them down. So I'm actually going to do this next part off camera, because I need the space here, and I'll be back in a minute. Okay, now I'm going to go ahead and get the front panel back on. At least part of the way. I'll probably just put a couple screws in for now. Screws are in the top and the bottom. Alright, there's one. Around here. Let's get one in the top. Go through and fix that up later. And then what we need to do is flip this back on its side and reconnect those two connectors to the RF amp board. Two connectors I'm referring to are this flat one here, single row. Make sure you got them lined up, because that one doesn't have a key, and then there's this one which does have a key. That's a 2-row. Alright, so now what we're going to do is we're going to get the oscilloscope back out, and I'm going to disconnect this wire here from the A16, and we'll hook that back up to the scope and run through the tests again. And then if that looks good, we'll go through and I'll show you the test that I wasn't happy with on this other AT1 attenuator board here. Okay, so if you remember in the last video, we were in the troubleshooting section of the manual, and I meant to run this front end check in the video and I forgot to record it. So what was happening is, there's 4 tests they have you run with special functions after connecting the instrument a certain way, and the ones where the pad is switched on, which is the special function 1.2 and 1.8, there was no output on the scope. So that's the point we determined the attenuator was not working. So I've got it set up again, and just as a reminder, so what we do is we set the signal generator to 11 megahertz at -30 dBm. We connect it to an AC coupled 50 ohm terminated scope, and then you fine adjust it so that the waveform is 4 divisions peak to peak. And then what we do is we disconnect the signal generator from the scope and plug it into the input on the instrument, and then this W8 connection here, which is on board A16, that comes from the front, you connect that to your scope. I'm using an SMC to BNC adapter. You leave the scope 50 ohm terminated the whole time. Okay? And then what they have you do is they have you key in these special functions, and they tell you how many divisions the waveform should be on the scope. And again, we're ignoring this annunciator status section, since my 8902A is a newer serial number that does not have the annunciator LEDs. So let's punch in special function 1.1, and that should be 3.9 to 4.1 divisions. And as you can see on the scope, it's right on 4 divisions, so that's good. Okay, and let's see, there's the moment of truth, 1.2. This one wasn't working at all before. Alright, and it wants 1.2 to 1.4 divisions, and we are right there, so that's awesome. So for 1.7 and 1.8, since there's gain, it wants us to reduce the scope's vertical gain by 10. So we're at 5.6 millivolts a division. We're going to change that to 56. Okay, so let's see, special function 1.7. And it is looking for 5.7 to 7 divisions, and we are at 1, 2, 3, 4, 5, 6, so that's perfect. Okay, and then lastly 1.8, special 1.8, and this one is 1.8 to 2.2, so I'd say we fixed the, it's actually a switch and an attenuator in the front end. It has the same package as other HP attenuators, and that plate on the top of it can be configured with different pads depending on what it's for. So we're looking good though, that part's fixed. Let's take a look at this other attenuator I mentioned earlier. Okay, so we're going to check the other attenuator now. It's called AT1 and it's right here. And it's a 0 to 7 dB stepped attenuator. They don't use all of it in this unit. There's one of the technical descriptions earlier saying they're only using certain steps out of it. But we're in the troubleshooting guide on the next page here. And it's called the input attenuator and 5.25 megahertz high pass filter check. So the first step is to set your signal generator to 5.25 megahertz at negative 33 dBm, connect it to a 50 ohm terminated scope, and adjust the level on the signal generator until you're at 15 millivolts peak to peak. So with my 8644B, I had to change the level to negative 33.5 dBm to get it to 15 millivolts on the scope. And then what it wants us to do is we need to change this connection here. Let me move the camera. So this is the AT1 board, and I disconnected the SMA connectors. I put some SMA to BNCs on here. So this is the input and this is the output. So it wants us to connect the input from the signal generator to the input, and then it wants us to connect the output to the scope and leave the 50 ohm terminator in the scope. Okay. Alright, let's go back here. Okay, so we need to go through these special functions here, and what it has us do is increase the level on the signal generator by 10 dBm, and then step through 10, 20, 30, 40, 50 dB of attenuation on the receiver. So let's here press special function 1.1, and that's what we want. We want 13 to 17 millivolts peak to peak. Then I'm going to jump over here to the signal generator and set it to minus 23 dBm or so. We're going to go down just a step of 10. Okay. And then we need to now press special function 1.3. And we are at 15 millivolts again. Let's go to special function 1.4. And let me step over to the signal generator. So now we're around minus 13. So we are good. We're at 15 millivolts peak to peak still. 1.5. Alright, so I've got the signal generator around negative 3 dBm, and we are still at 15 or so millivolts. 1.6. I'm going to set this to plus 7 dBm on the signal generator. I'll be right back. Okay. So we're good. We're at 16 millivolts, but the range is 13 to 17, and I don't really have the accuracy dialed in too good. I'm just looking to get a rough idea if this attenuator is working at all. All right, and then we want special function 35. Well, that's not doing anything. I'm going to go set this to plus 17 dBm. Oh, I got to type in 35.0. I wasn't doing it right. Special 35.0. There we go. 13 to 17 millivolt. We're at 15. So that attenuator is good. I guess I must have been doing something wrong the other day when I was checking that out. in the midst of trying to narrow down if it was this one or the fixed 10 dB up front. So I'm pretty happy with that. I'm going to go ahead and reconnect these things, and we'll try using this thing the way it's meant to be used and see if it works now. Alright, well, I've got it back together. Seems to work well. I've got it hooked up to my Rohde & Schwarz SML01 signal generator at the moment. And what I've been doing is I've been measuring the distortion level of the modulated signal. I noticed in the past with my HP8644B, I seemed to get different levels of distortion on tuners that I was working on depending on what frequency I was tuned to. And I was thinking it might have had to do with interference from the radio stations nearby, but in some cases it was happening when there's nothing on that frequency, and I even checked with the spectrum analyzer. So I've been playing around here. So I've got this Rohde & Schwarz, I think it's, what's it set to? It's at 92 megahertz, negative 20 dBm signal. I've got FM modulation turned on. We've got a 1 kilohertz tone, 75 kilohertz of deviation. So the way this thing works, let's see here, I'm going to preset the instrument. So when you preset it, it'll automatically tune to the strongest signal. And I do have this hooked up to the GPS disciplined oscillator because I haven't adjusted the internal oven or anything like that yet. So we can see our 92 megahertz. And if you press the FM key, we'll see our deviation around 75 kilohertz. And if you press the gold key and then AM, you'll get audio frequency, so that's our 1 kilohertz of modulation. And then if you press the gold key and then FM, you'll get audio distortion, which is 0.06%, which is pretty good. It's actually better than the HP8644B in most cases. But the important thing here is that if I change this guy here to, let's see, frequency 98.3 megahertz, it'll take a second, but it'll tune to it. It's the same. It's 0.06% distortion. Now I'm going to go ahead and disconnect this and hook it up to my 8644B. And we're going to set this to 98.3 megahertz. And FM 75 kilohertz and amplitude negative 20 dBm. So this should be an apples to apples comparison. I've got it on the mode 1, which is the lower distortion mode. And we're getting 0.17%. Now if I change the HP to, let's try 92 megahertz since that's what I did on the Rohde & Schwarz. It'll tune it. And 0.09, that's a lot better. Now I notice if I go to 99 megahertz, 0.06. So this 8644B, the distortion seems to vary depending on what frequency you have it set to, which is not ideal. I was going crazy in the past couple months on a couple tuners. You know, you don't really need a low distortion signal generator to do the actual alignment, but if you want to spot check it after you're done to make sure everything's good, it doesn't hurt to have the capability. But yeah, I was seeing varying readings like that, so that's not good. So I guess I'm probably gonna end up switching to this Rohde & Schwarz, which is actually a pretty nice unit. It has FM stereo built in as well, so I mean, I like my wall of HP here, but I can replace these two units with that one Rohde & Schwarz, so I guess that's what I'll probably be doing. Alright, well I think that's all I'm going to do in this video. I think I'm going to make another video where we actually go through kind of the quick start guide and go over some of the more basic features of the machine and give you an idea of what it can do. The only thing is I don't have the power probe for it, so we're not going to be able to test everything like the tuned RF level. Certain things you can only do with that. And those things go for way too much money, so I'm probably never going to get one unless I've come across one for free or cheap. So yeah, I'll probably be back in a couple days with another video, part 3. So thanks for watching. I hope this helps someone.